Science Frontiers continues on TLC.
From them, a steady stream of subatomic particles blows throughout the solar system and beyond. We call it the solar wind. Particles from the solar flares and wind can strike our upper atmosphere, setting off a spectacular light show called the Aurora Borealis, or Northern Lights. For us, the sun is a kindly giant. It warms our world just enough for life to take place. Plants convert sunlight into usable energy. It's the very foundation of the food chain for all living things. On the other hostile alien worlds, we would perish instantly without special protection. But they are also children of the sun, to be treasured for their revelations about the mysteries of nature. As the solar cloud began to cool, lighter elements formed the mighty gas giants of the outer solar system: Jupiter, Saturn, Uranus, and Neptune. But closer in, higher temperatures and pressure created the dense rocky planets: Mercury, Venus, Earth, and Mars. In 1971, Mariner 10 gave us our first close-up look at Mercury, the nearest planet to the sun. We found a desolate, battered world, pockmarked with meteor craters, a testament to the violence of the early solar system. Our rocky planets and moons were built up by collisions like these, as small pieces of matter came together. After the planets formed, the early bombardment continued. Mariner 10 showed us a Mercury that looked much like the moon. This was our first proof that the moon was not a special case. A massive rain of rocks and debris took place throughout the early solar system. We have since found more proof: impact craters on Venus, on Mars, and on most of the moons of the outer planets. Here was a primal force that helped to shape our solar system. Today, the bombardment is still underway at a much lower rate, as comets and asteroids occasionally strike our worlds and moons. "1994 brought the most powerful collisions in recorded history, as fragments of a broken comet smashed into Jupiter. Limb of the giant planet up to 1,200 miles high. A fireball would blossom a few minutes after Traveling at enormous speeds, the particles released up to 100,000 times more energy than the largest nuclear bomb. Venus is our sister planet, about the same size as the Earth, with almost the same gravity. But it lies 25% closer to the Sun. The difference is just enough to make Earth a cradle of life and Venus a living hell. The water fell as rain, forming the life-giving oceans. But the Sun gradually brightened and Venus got hot. Unlike Earth, the face of Venus is forever hidden by clouds. But the Magellan spacecraft has pierced this mysterious veil with radar, revealing a dramatic volcanic landscape with low plains surrounded by highlands. At the Jet Propulsion Laboratory, a computer has transformed the radar images into a soaring journey over the surface of Venus. We saw lava flows and towering volcanic mountains up to 7 miles high. This one, Sif Mons, looms a mile above the surface. We found lava domes unlike any in the solar system, shaped like pancakes. They rise up to half a mile high and average 15 miles across. They may be composed of sticky lava. We found unique circular volcanic vents called corona. Artemis is the largest, as big as the western United States. Artemis has a spectacular canyon so beautiful, it would be a top tourist attraction on Earth. We saw strange volcanic features like spiders with radiating cracks. And an unexplained mystery, lava flow channels up to 4,000 miles long. No one knows how they could flow that far without cooling. The planet is riddled with fractures, cracks, and faults, evidence of past earthquake activity on this tortured landscape. We travel over a large fault valley 600 miles long, formed by an ancient upheaval of the crust. Next, we skim the summit of the towering 2-mile-high volcano Gula Mons, surrounded by lava flows. Do volcanic eruptions still take place on Venus today? Magellan did not answer that question, but we did make a startling discovery. The surface of Venus is relatively young. A huge planet-wide volcanic outburst might have completely repaved the surface around 500 million years ago. Or instead, smaller volcanic flows may erupt every few million years. Finally, we soar over the rugged highland area known as Alpha Regio. Its tortured surface is composed of mountains, valleys, lava flows, and faults. This is one of the most cracked, squeezed, and stretched landscapes anywhere on Venus. What kind of forces created these awesome sights? And are they still at work today? Magellan has shown us that volcanic activity was a major tool in shaping the surface. But many questions remain unanswered, and years of study are ahead as scientists examine the wealth of data from Magellan and try to unlock the secrets of Venus.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
In 1969 came man's greatest adventure. For the first time, we journeyed to the surface of another world.
Houston, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind. This has got to be one of the most proud moments of my life, I guarantee you.
Between 1969 and 1972, 12 astronauts explored the surface of the moon as the world shared in this triumph of the human spirit.
Man, I'll tell you, Indy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail. I can't believe we came over those mountains. We did. It's just a beautiful little valley. Wow, what a place. What a view, isn't it, John? It's absolutely unreal. Look at the size of that rock. The closer I get to it, the bigger it is. There is orange soil. Light gray material on either side. Oh, man, that's incredible.
Thanks to the Apollo astronauts, we know more about the moon than any body in space, beyond our own. But a puzzling mystery remains. Why is Earth the only inner planet with a large moon? And where did it come from? Shortly after the birth of the solar system, a planet the size of Mars might have collided with the Earth, throwing off material that reformed into the moon. A heavy bombardment of meteors rained down on the early moon, leaving craters of all sizes. Then volcanic lava flows poured across the surface, creating lowlands or maria, visible from Earth as smooth, dark areas. The rest of the moon is composed of rugged highlands. $3 billion years ago, the moon became a dead world. Today, only meteor strikes disturb its surface, leaving a dusty powder and occasionally craters. For 200 years, we looked at this mysterious fuzzy ball and wondered at its secrets. Did life exist on our neighbor in space? At the turn of the century, Percival Lowell believed he saw canals built by a dying Martian civilization in a desperate attempt to water its crops on a world growing drier and drier. In the early 60s, some astronomers still believed that seasonal changes in color were caused by Martian vegetation. Today, we know those changes are triggered by giant dust storms. Our robot explorers have revealed the true Mars, a barren planet filled with dry, dusty deserts, cratered plains, lava flows, and giant volcanoes. The largest volcano, Olympus Mons, towers 15 miles above the Martian landscape, 2.5 times higher than Mount Everest. Its base is 335 miles across. At the top is an immense caldera of overlapping volcanic outlets, almost 50 miles wide. We don't know if the volcanoes of Mars are still active today. Here is one of our most astonishing discoveries, evidence that water once flowed on Mars. We saw elaborate dry riverbeds and channels, some of them hundreds of miles long. Mars once resembled Earth. Those days are gone forever. With its lower gravity and its distance from the sun, Mars has evolved into a cold, dry world, devoid of life. This may be all that's left of a dried-up lake, photographed from Martian orbit. Despite its hostile conditions, Mars bears the closest resemblance to Earth of any body in the solar system. It's half the size of our planet, but with no oceans, it has almost as much land. A day on Mars is about the same length as one of ours. A Martian year is 2 Earth years long. And there are 4 seasons. The polar caps shrink in summer and grow larger in winter. Mars also has weather. An ice haze or fog often develops in canyons and valleys in the early morning hours. There are wispy storms of water and ice, winds, and fierce dust storms that can blanket the entire planet. The space age has only increased our fascination with Mars, and sometime in the 21st century, a human expedition will almost certainly take place. The outbound journey will last 6 to 9 months in a ship that might be powered by nuclear engines. In the 1960s, nuclear rocket engines were tested in the Nevada desert. They may offer the most efficient and quickest route to Mars. Once the ship is in Martian orbit, shuttlecraft will take the explorers down to the surface. What will we find on man's first journey to the Red Planet? In 1976, 2 Viking spacecraft gave us a glimpse into the future.
ACS is close to vertical.
Nav is green for touchdown.
ACS is green, 1.5 degrees per second max, 0.2 Gs.
Touchdown, Win. Fantastic. 16 kilobits confirmed.
The Vikings showed us a rugged landscape of rocks and sand dunes, tinted red by iron oxides. Is a permanent base possible on this hostile, far-off world? The frozen water of Mars is a great resource. The North Pole has large volumes of ice and an amazing series of ice cliffs with layered terraces. This strange sight might be the result of changes in the Martian climate over millions of years. Elsewhere, there may be plenty of ice buried underground, just below the rocky surface. If we can reclaim the water, we can drink it. We can use it to grow crops in greenhouses. We can split it into hydrogen for fuel and oxygen to breathe. 500 million miles from the sun, we enter the realm of the giants. Jupiter is large enough to hold 1,000 Earths. Its outer layer is a ball of gas, mostly hydrogen, with some helium. If Jupiter was 80 times more massive, it would have become a star. This is a planet in motion, rotating once every 10 hours. It's ringed by alternating bands of jet stream winds, traveling in opposite directions. Eddies are stirred up between the opposing wind currents in a swirl of abstract art. Jupiter is colored in reds, browns, whites, and blues from clouds of frozen ammonia and ice at different altitudes. The Great Red Spot is a giant hurricane twice the size of Earth. It was first seen nearly 300 years ago. It continues to rage on, rotating once every 6 days. Deep inside Jupiter, the temperature and pressure gradually rise until hydrogen becomes a liquid, and finally a liquid metal. At the very center is a small rocky core. This huge rotating mass generates an immense magnetic field up to 8 million miles across that is constantly bombarded by the solar wind. This mighty colossus is circled by 4 major moons. Each is a unique world of its own. On the right, Europa. On the left, Io, both about the same size as our own moon. Through the remarkable eyes of the 2 Voyager spacecraft, this amazing family of worlds has been revealed to us for the first time. Io, the closest moon to Jupiter, is racked by volcanic eruptions. It's heated by a gravitational tug-of-war between Jupiter and 2 other moons, squeezing and stretching this tortured world back and forth. The result is a huge cloud of charged particles that takes the shape of a giant donut as Io circles Jupiter. Europa resembles a cracked eggshell with a smooth surface of ice crisscrossed by giant streaks. These might be cracks in the ice that are still being formed today as Jupiter's gravity heats Europa. And beneath the frozen surface, it might be warm enough for an ocean of liquid water. Could such an ocean contain simple life? We can only guess at the true nature of this mysterious world. Ganymede is the largest moon in the solar system, slightly bigger than the planet Mercury. Patterns of ridges and grooves crisscross the entire surface. They were apparently created as this icy world began to cool billions of years ago. On this jumbled terrain, there are many separate blocks that slipped past each other in those ancient times. Their boundaries resemble large earthquake faults. Callisto is the outermost of Jupiter's 4 large moons. It has a smooth, icy surface that's completely covered with shallow craters. This is the most heavily cratered body ever discovered. Callisto has remained this way for 4 billion years, virtually frozen in time. As we leave mighty Jupiter, we look back at its ring, glowing in the sunlight, just one of the many discoveries by the amazing Voyager spacecraft. Like a modern Christopher Columbus, the Voyagers had revealed 4 new worlds and a giant planet. But a lot more was yet to come. Magnificent rings and its pearl necklace of moons, Saturn is the most beautiful object in the solar system. From Earth, we can see half a dozen major rings, but Voyager discovered thousands of tiny ringlets. Discovered dark spokes that move quickly around the rings, only to break up and vanish a few hours later. They may be dust particles caught up in Saturn's rotating magnetic field. Saturn is our 2nd largest planet. Like Jupiter, it's a rotating ball of gas and liquid. Saturn also has bands of jet stream winds 4 times as fast as Jupiter's. And there are oval-shaped storms, smaller versions of Jupiter's Great Red Spot. In 1990, the Space Telescope photographed a gigantic storm spread around Saturn's midsection. Storms this big arise on Saturn about once every 30 years. They may be caused by the changing seasons on this distant world. Titan, the 2nd largest moon in the solar system, is truly unique. It's our only moon with a sizable atmosphere. Shown here in blue, it's a heavy blanket of nitrogen, 50% thicker than our own air. Sunlight creates a smog-like haze that completely hides the surface of Titan. We can only guess what lies beneath. The sky may be filled with methane clouds and a drizzling rain. Below it, a frozen surface dotted with hydrocarbon lakes. Titan's atmosphere is a sample from the distant past. It may teach us more about Earth's primitive atmosphere as it existed 4 billion years ago. Saturn's other moons are much smaller all of them frozen balls of ice with some rock. The Voyagers gave us a grandstand seat. As they sped away, the Voyagers looked back in a final farewell to majestic Saturn. But the mission was not yet over. Every 179 years, there's a rare alignment of the outer planets that makes a grand tour possible. Voyager could visit all 4 giant worlds by using the gravity of each one as a slingshot. As Voyager 1 headed out of the solar system, Voyager 2 charted a new course for Uranus and Neptune. Uranus is our only planet that's tilted on its side. It was either formed that way or knocked over by an ancient collision. 4 times wider than the Earth, Uranus is surrounded by a faint band of rings. To the human eye, Uranus is a hazy ball with no visible features. But computer processing has revealed atmospheric bands of wind. Seen from the South Pole, they form an eerie eyeball in space. With this 8-frame movie, we discovered that Uranus rotates every 17 hours. 12 years after it began, the historic odyssey of Voyager 2 came to an end at Neptune, 3 billion miles from the sun. Uranus and Neptune both have heavy cores of rock and hot liquid, topped by atmospheres that are rich in hydrogen. Neptune's deep blue color is caused by methane in the atmosphere. These bright streaks are clouds of frozen methane. And Neptune has its own version of Jupiter's Great Red Spot, a giant rotating storm called the Great Dark Spot. On Neptune, we have found the strongest winds of any planet, up to 1,500 miles an hour. Neptune's large moon Triton is probably a captured planet because it orbits in the opposite direction to Neptune's rotation. This super cold world of ice is covered with an amazing assortment of strange terrains. As we scan the surface, we see the result of Triton's remarkable evolution. First on its own for several billion years, and then under the domination of mighty Neptune for several billion years more. And Voyager's final surprise, dark smudges visible in the lower part of the picture, may be evidence of nitrogen ice volcanoes, several of them erupting as the spacecraft went by. On the left, the source of the eruption. A long cloud trail streams off to the right as nitrogen gas and dark dust particles are thrown several miles into space. Pluto was not on Voyager's grand tour, but we believe it's very similar to Triton. This is an artist's view of Pluto. In the sky, its moon, Charon. It was a dramatic sight as Voyager 2 looked back at giant Neptune and its fascinating moon Triton, the final outpost of our solar system. As the Voyagers sail on into deep space, they leave behind an amazing legacy. They have truly opened our eyes to the wonders of the outer solar system, but they have also raised far more new questions than the old ones they have answered. Beyond the orbit of Neptune, we believe there's a swarm of 1 trillion icy chunks left over from the creation of the solar system. Every so often, one of these particles plunges inward to a close orbit around the sun. As it greets the solar furnace, it's transformed into an object of spectacular beauty, with a glowing head and a streaming tail. We call it a comet. In the Middle Ages, comets were greeted as mystical visitors from the heavens. Often, they were seen as evil omens, evoking fear and terror. Scientist Edmund Halley was the first to discover that comets orbit the sun. Just as he predicted, the great comet he witnessed returned 76 years later in 1758. 1910 brought a close encounter. Many people feared that life would be snuffed out by poison gas as the Earth passed through the tail of Halley's comet. The fears proved unfounded, and the sight of the comet stretching 1/4 of the way across the sky was the event of a lifetime. In 1986, the Earth was in a poor position to view Halley's comet. It took a special effort to see it, but those who journeyed far from city lights caught a glimpse of the most famous comet in history. To the human eye, it was far less than spectacular. But this would prove to be Halley's most important visit ever, because this time it was met by 5 spacecraft from Western Europe, Japan, and the Soviet Union. The European Space Agency's Giotto penetrated inside the comet's glowing head to photograph the hidden nucleus. For the first time, this dirty snowball was revealed to us, a lumpy, potato-shaped object 9 miles long with a black chemical coating. Jets of gas stream off its surface as the sun heats this primitive object more than 4 billion years old. With the dawn of the space age, we have truly seen our solar system for the first time. We have seen amazing worlds, each in their own way, molded by nature's tools. Heat, gravity, and the bombardments of the early solar system. We have seen how each unique body has evolved according to its composition, size, and distance from the sun. And these alien worlds have given us new insight into the most unusual planet of all, circling the sun in this narrow zone of life. But our quest for knowledge goes on. New American spacecraft will orbit Mars and land on its surface. A 2-foot-long rover will explore the Martian terrain. In 1999, a 4.5-foot-long Russian rover will journey across the Martian landscape, navigating over rocks and sand dunes. The same mission will include a French balloon that can float over the surface, taking panoramic pictures of the view below. In December 1995, Galileo begins a 2-year mission to photograph the moons of Jupiter in finer detail than ever before, also dropping a probe into Jupiter's atmosphere. In 2004, Cassini will orbit Saturn, studying its moons and releasing a European probe into Titan's atmosphere. And we may get our first close-up look at Pluto early in the 21st century. In 5 billion years, the sun will begin its final death throes, growing to an angry red giant as it runs out of hydrogen fuel. Long before then, life on Earth will cease to exist as the sun grows steadily hotter. The search has already begun for worlds around other stars. may be witnessing the birth of a new solar system, a flat disk surrounding the star Beta Pictoris. It offers hope that planets are common elsewhere. So one day, in the far distant future, mankind may embark on a final journey to the stars, to a new planet Earth, with only memories of the magnificent solar system we once called home.
Next world. You're watching the Learning Channel.
For thousands of years, man believed he was alone in the cosmos.
We've always made heaven an almost infinite distance from Earth.
Yet man was determined to push back the frontiers of his experience.
When you're out 250,000 miles away, it's almost like you're no longer part of it. You're standing back and watching the world go by.
And now we stand on the edge of eternity, confronting the wonder and the danger that lies in space.
Beyond what is known lies an unexplored world of shadows and phantoms. A land that knows no limits of time or space. From the dawn of discovery to the nightfall of catastrophe. Journey to a universe of the unexplained, the unforeseen, the unbelievable. A place beyond reality, where no question will go unanswered. A place where myth and legend are law, superstition a science.
It's time for our journey to begin. Our destiny has brought us to the threshold. Our dreams will help us to cross it. Space, the last uncharted world. Knowledge surrounds these library walls, and with these instruments, that knowledge can be ours. In 1903, while Wilbur and Orville Wright were laying the foundation for aviation, writers and filmmakers were looking well beyond earthly travel. Those futurists saw our inevitable journey to the stars as a natural step in man's evolution. These early films were an amusing glimpse into a fantastic and imaginary world. But it was not these celluloid voyages that first began our conquest of space. It was something far more sinister. In the early 1930s, Germany first experimented with sophisticated ways of delivering explosives to their targets without a pilot's guidance. They developed rockets with internal controls to rain death upon England, hundreds of miles away.
Hitler and Albert Speer were looking for missiles that could deliver warheads against Allied targets. And that was what the Nazis were primarily concerned with, was fighting a war.
In spite of terrible damage, the war ended before these experiments could be perfected. However, the heated conflict of the Second World War soon cooled off into a competitive struggle between the United States and Russia, and each side sought to acquire the rocket technology and scientists produced by Nazi Germany. German scientist Werner von Braun is considered to be the architect of America's space program. Von Braun and his team took the technology from the German V-2 rocket, which had been created for destruction, and applied it to the development of the chariots that would take man to new worlds. On October 4th, 1957, the space race began in earnest. On that day, the Soviet Union launched Sputnik 1, the world's first satellite. Reaction was immediate, a mixture of wonder and concern.
They came from out of nowhere and put up Sputnik, and the world was astonished, was frightened, was surprised, and was looking for the United States of America for an answer.
The United States did answer, but unfortunately their space program got off to a rocky start. Because of these failures, the Soviets always seemed to be 1 or even 2 steps ahead of the United States. And on April 12, 1961, Yuri Gagarin became the first man to orbit the Earth. And it seemed the United States would never catch up. The Soviets were justly proud of their accomplishments. But less than 1 month later, in a suborbital flight, Alan Shepard became the first American in space. It was this flight that inspired President John Kennedy to commit the resources of his nation to putting a man up on the moon by the end of the decade.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
America moved forward. Mercury, Gemini, and then Apollo.
We were serious about going higher, farther, and faster, and coming back. We know it's a high-risk environment. We're prepared for high risk. We enjoy doing this exciting stuff on the leading edge of technology.
In July of 1969, President Kennedy's dream was realized. Man walked on the moon. Mission after mission explored this barren land, and closer to home, the colonization of space became a possibility. Projects like Skylab and the Space Shuttle were developed in the 70s to create a working environment in space. In a symbolic flight in 1975, America and the Soviet Union met in the heavens, cooperating for the first time in the Apollo-Soyuz mission. But while both of these nations' space programs were marked by great success, they were also scarred by tragedy as well. On January 27, 1967, astronauts Gus Grissom, Edward White, and Roger Chaffee were training for their first Apollo mission when a spark set off a horrible fire that swiftly snuffed out their lives.
Those 3 lives, the lives of Gus Grissom, Ed White, and Roger Chaffee, probably contributed more to our success in the Apollo program of landing on the moon and bringing man home safely to Earth than any other one thing or anybody else in the entire space program. What came out of that fire was almost a complete rebuilding and remolding of the entire Apollo program, from the hardware to the techniques of our training to our operational procedures. And I think it forced us individually to stop back and look at what we were trying to do.
Even after successful launches to the moon, troubles remained. In April 1970, over 200,000 miles away from Earth, an explosion crippled the Apollo 13 spaceship. Through amazing ingenuity and very good luck, tragedy was averted. Barely.
Apollo 13, probably more than anyone will ever realize today, was a flight in which we came closer than I ever want to come again to losing 3 human beings, actually losing them in space. And Apollo 13 probably produced the greatest level of cooperation between industry, the educational institutions, and government in this country than has ever been seen and perhaps ever will be seen again.
Perhaps the most searing image of the risks of space travel occurred on January 28, 1986, when the world witnessed the explosion of a dream and the deaths of 7 brave men and women. The Space Shuttle Challenger fell victim to a combination of bad weather, bad equipment, and worse luck. In spite of these tragedies, perhaps because of them, man continues to explore the heavens.
There's never been an astronaut who got on a spacecraft, whether it was Mercury, Apollo, or even Shuttle, who didn't fully understand the risk involved and who wasn't willing to take them.
Triumph as well as tragedy have always been part of man's exploration of the unknown. So too is confronting unexplained phenomena. NASA and those who pioneered the space program chose to convey to the world an image of ultimate confidence. Men with the right stuff were certainly above picking lucky numbers to accompany the names of their spacecrafts. Or were they? Superstition can survive in any environment. Every one of the first Mercury spacecraft had a 7 after its name. Though engineers and astronauts are among the most pragmatic men on Earth, apparently they felt a little luck was to be encouraged. One of the more engaging facets of our voyages into space is the way in which our humanity and spirit continues to go along for the ride. After the tragedy of Apollo 1, it is easy to see why the next manned flight number was a lucky 7. Ironically, there were those at NASA who argued against numbering a mission 13. They were overruled, with almost tragic results. But as we can see, there have been many flights, many numbers, and a lucky 7, while it may help, is no substitute for good planning and simple bravery. Decades of space exploration have resulted in widely publicized stories of great scientific discoveries. There is speculation that some reports have been purposely held back from the public. These tales include man's first encounter with alien beings. Since man first began exploring space, these rumors about encounters with extraterrestrial life have persisted. Is it possible that these meetings have occurred? Or is it just the overactive imaginations of a few tabloid editors?
That's a characteristic of exploration. In fact, if you go back even to the days of the sailing ships, we'd seen mermaids. And as far as sightings of aliens in space, there's a vast literature of this published. There's a worldwide story about Apollo 11, our first moon landing, which I guess must not have been dramatic enough for some people, that there were alien spaceships lined up along a crater when the Apollo ship landed.
Fueling this speculation have been odd photographs taken by the astronauts, unexplained lights floating in space. And while astronauts stoutly maintain that they have never seen anything resembling alien life, it's not, it seems, for lack of trying.
I'd love to have seen a UFO, or I'd love to have seen and come back and be able to say something about some new extraterrestrial life. But unfortunately, I can't. I don't know anyone who can at this point in time. I will admit, when we were on the surface of the moon driving that lunar rover around, every time we came across a set of tracks, we did stop and take a good look at them and make sure they were ours and not somebody else's.
We haven't encountered otherworldly voyages yet. Though most astronauts immediately dismiss these rumors of past meetings, they are not as swift in ruling out the possibilities.
It's a certainty that life is out there. And I think not only is it out there, but it will be very recognizable. It will be very similar to life forms as we know them.
Certainly there has to be other life out there in outer space. Statistically, mathematically, I think you can prove it over and over again. Why should we be so egotistic to believe that life is created here on Earth and nowhere else?
Bigger, faster, smarter. Words that describe the hardware man will need to explore space into the next century. This technology is in various stages of development. Some are on the drawing board, others in full-scale operation. First launched in May of 1981, the Space Shuttle is a design created for the future, the first step in the colonization of space.
3, 2, 1, We have ignition. We have ignition of the solid rocket boosters and liftoff. Liftoff of America's space shuttle, and the space shuttle has cleared the tower.
The shuttle has more capabilities than simply a way in and out of space. Here's a huge laboratory that did an immensely good job as not only a transportation system, but also a laboratory in space.
Working in an area free of the boundaries of gravity gives scientists the opportunity to perform and create new experiments that have a multitude of applications. And beyond the flights of the space shuttle, the next goal is a voyage to the red planet of Mars.
If we want to go to Mars, we better have someone at least know what it's like to be in space for 3 years. That's a long time.
I think we're going to see colonization one day of Mars. I think we're going to see a civilization grow up and build up on Mars. I think it's going to be a natural evolution of mankind on this Earth.
I think the possibility that the United States and the Soviet Union will work together going to Mars is increasingly likely, just because the endeavor will be so expensive. I think it was in Ray Bradbury's Martian Chronicles, the line, the first Martians are us.
But why stop there? Some believe that man's journey into space is only limited by his imagination.
I would say let's don't settle Mars. Let's go out and see what's on some of the moons of Jupiter or something like that. So I believe we should keep the pace up, explore every part of the solar system, every part of the universe, and build the best spaceships and flying vehicles.
At present, we're well past Saturn through the proxy eyes and ears of Voyager, America's unmanned space probe, traveling millions of miles to the farthest reaches of our solar system. But man's hopes for the near future of space travel are propelled by the space station, a vehicle America has pledged to have in orbit in the next 15 years. The United States space program is committed to having a permanent station in orbit by the end of the 20th century. It will have up to 8 astronauts, and it'll be self-sufficient in every way. The orbiting space station will hover 300 miles over the Earth and will offer man the opportunity to view the universe as never before. In order to see what lies ahead in this near future, we must journey there. Well, ready?
One moment. I'm having trouble locking into the destination coordinates. There. I think I've got it. The portal is set for September 2003. Your destination is the main deck of the laboratory module aboard Spacelab 1. This facility has been in geostationary orbit for 2 years, 7 weeks, and 5 days.
Do I need any special equipment?
No. Oh, but my circuit shows some thermal malfunction. It might be a little cold.
Thank you. Back in no time. "300 miles above the Earth, it is eternal night. But here, humanity has brought light and life to this void. Our future may begin within these walls. If man is ever to learn to live and work in space, these are the first steps he will have to take. This low-gravity environment is perfectly suited for the creation of new technologies, new sciences. In this station, men and women can live and work together to consolidate our now tentative foothold in space, bringing the life the Earth contains into a new world. Sights and experiences that once would have been unthinkable are here, a part of everyday life. This is a window into a landscape that has infinite dimension, infinite opportunity. Space is far from empty. It is full of promise. And in the future, when man looks at the stars, some will glitter with the light of his accomplishment. For a few of these stars will be space stations like these. carrying his dreams through the heavens. How long have I been gone?
Only an hour. How was your journey?
Oh, fascinating. It's obvious that the technology we need to continue our journey into space is already within our grasp. Some of that technology is already enriching our lives in ways we're not even aware of. Man has been exploring space for over 30 years, and some of the technology developed for these voyages has become an integral part of our lives. We have come a long way in a very short time, and experts are unanimous on one thing. We have only just begun our journey.
I believe that going into space is a major event in human evolution, in the evolution of planet Earth. Probably as significant as the first sea creatures crawling out on the land.
We need to get into space reliably and low cost, and that'll open up space to all these other things. Then I can start romanticizing about trips to the planets.
Going to places like the Moon and eventually Mars, I think, are going to unlock some of the secrets, some of the answers that mankind has been looking for eons and eons of years. We know so little about ourselves and where we came from. I don't expect all of that to be answered simply by a couple of people going on through space in a spacecraft. But inch by inch, generation by generation, I think we'll begin to understand ourselves a little bit better, know a little bit more about ourselves, and in essence, allow ourselves to be more part of our own environment, and our environment is space.
Time is all that stands between us and the inevitable conquest of space. To understand the need for exploration, we must look no further than our own history. For the passion that led Columbus and Magellan to discover new worlds is the spirit that lives within all of us. Space, a journey that will never end. It is our destiny.
Secrets and Mysteries presents information based in part on theories and opinions, some of which are controversial. The producer's purpose is not to validate any side of an issue, but through the use of actualities and dramatic recreation, relate a possible answer, but not the only answer, to this material.